Hi there, my name is Will, and today I'm going to clarify the differences between the ForEach and the ForEachItem task. Now, we've seen from a number of users that you've seen both of these tasks, which are pretty similar, but you're unsure of which one to use in different scenarios. So I'm going to break down what each of the tasks does, and then talk about a few different scenarios where you might want to use each one. Now, starting off with, what are these tasks? Now, these fall into the category of flowable tasks, which control your orchestration logic. So instead of this being a task that actually processes work on your Kestra instance, instead this helps control how that should be done. Now, in this case, both of these task types loop over a subgroup of tasks. So you might have a couple of tasks that you want to be able to run, and you want to hand data to it and basically run it a bit like a for loop, for example, hence the name ForEach in both of them. Now, let's have a look at a couple of examples of these both in action and discuss the differences. To start with, we've got a ForEach example here. Now, this is simply set to have 3 values. So the idea is that the subset of tasks will run 3 times for each of these different values. And we can access this value using the expression taskrun.value. So as you can see here, this first return statement here will tell us value 1. If this if statement is true, which is looking for a value of value 2, then it will also print this after return as well. So we should see it say the before return 3 times and the after one once in the middle. So let's execute this and see this in action. And as we can see here from the Gantt chart really easily, we can see that it was able to successfully do the for each. We can see that it says before if value 1, and then the if statement does not pass, so therefore we do not get an after. We see value 2, but the if statement is true. So here we also get after if. And then we can see here value 3 as well. So we can see that that works exactly how we would expect it to. Looking back at the flow here, the key thing that differentiates this to ForEachItem is this values property. Now, as you can see here, we're passing pretty simple data in the great scheme of things. As you can see here, it's just a simple array with 3 string values inside of it. And this allows us to iterate through this. Now, it's worth noting that every single time you run a task, you're generating a task run. And a task run is, think of it like an execution for your task. Every single time you run your flows, you will have many task runs. And the more task runs you have, the greater the risk of your flow being slow. Now, to enhance performance in Kestra, we would encourage you to break things into separate executions. And that's where the ForEachItem task comes in, because instead of running all of these as separate task runs, which we can actually see from this Gantt chart, all of these are separate task runs. So for what seemed to be just one simple task has broken into quite a few now. ForEachItem will instead run those tasks as a subflow, which means it will create a whole separate execution for those blocker tasks, which helps then split up the work, and it stops having one execution have tons of task runs, which then can potentially impact performance, and instead break it up into chunks into separate executions. Now, you may be wondering, well, surely I should use ForEachItem all the time then, right? Well, no. Let's have a look at ForEachItem and have a look at where you might use this, and we can then compare the two to each other in a second. So here I've got a simple workflow. Now, this is going to be our subflow that ForEachItem is going to use. Now, this flow is going to need an input, which we're going to get from the ForEachItem task, and then it's going to simply just process it by printing out the orders to the terminal. And then we can read that out and print it to the logs. So now what we can do is create our ForEachItem in a separate workflow and then call this orders flow from that. One of the key difference here is, instead of using that values property where we can pass it an array of strings or values, we are going to instead pass it a URI or a file. So in this scenario, we have a task up here that is using DuckDB to query some SQL. And we're just simply querying this CSV file and getting a load of data from it. And when we run this task, we will generate an output that we can then use with lots of data. So let's have a quick look at that. And as we can see here, when we run that extract, we get this URI where I can preview that, and you can see there is tons of data here. Now, if we were to run this through for each, we would create many, many task runs, and we would start to see a hit in performance. Whereas instead, we can create a separate execution for all 100 of these separate rows. Now that we have our data and it's in a URI format that we can easily pass in as an expression, then what we can do is then point at our subflow. So here we can specify the namespace and the flow ID to make sure that we've got the correct subflow. And then we can also make it sure that it will wait for those subflows to complete before moving on to any later tasks, maybe a Slack notification to say it's all done. Wouldn't be very helpful if it's still processing all your subflows and then it tells you that it's done, but it's not actually done. So this is very worth having in scenarios like that. Now, transmit failed is also really useful in case one of your subflows fails. That will then fail this parent task to basically make sure that it doesn't proceed further. Now, this is important if you're going to use some of the outputs from those subflows later on. If you're not, and they're completely independent, then maybe you don't need this. And then, like we said earlier, we're going to need an input for each of those subflows. And as you can see here, we're able to specify them in a nice, easy list format. And here we can use the expression taskrun.items to be able to get each one. Now, one of the key differences with ForEach is we have this additional property here called batch. Now, this is how we're going to split up the data for each of the subflows. We've simply said here, let's pass in one row per subflow, and we're going to process that. So it gives you a lot of control here on how you want to manage that data. So we've got 100 rows here in our CSV file. Let's execute this and see what this looks like in comparison. Now, as we can see here, it's processing all of those subflows, and we can see it created 100 separate executions. And this view here makes it really easy to make sure that all of them were successful, and if any of them failed, we could easily see that. Now here, when I press on success, we can see all of those separate subflows created in here under the orders flow. We can also jump into the outputs tab here to see a bit of a summary of what happened with all of those subflows. So as we can see here, it ran it 100 times. All 100 of those were successful. We can see the base URL of the output. We can see any splitting and merging. So here we can see it was all splitted out. And here it's created an ION file for every single different one there. So it's easy for us to be able to see all of that data. And as you can see here, this task is much better suited at handling much larger workloads, especially where you've got everything in a file format or a URI, whereas the ForEach example is much better suited if you've just got a small amount of data that you want to just simply loop over. So just revisiting ForEach for a second here. Here we are specifying each of the values here. Now, if this is far too long, we'll start to see a slowdown in performance because instead we are only creating one execution, but many task runs for every single time we repeat this task here return. And so when I execute this, we'll see in the Gantt chart, we'll see return will appear 4 different times. Whereas in our previous example, we only saw the ForEachItem task and everything was broken into separate executions. One nice thing about ForEach as well is that this is concurrency limit. So what you can do here is basically control whether you want things to run in parallel or not. Now, if you set this to 0, everything will try and run in parallel. If you set this to a number greater than 0, like 2, this will only allow 2 things to run in parallel. So if you want everything to run sequentially, then you can put the value to 1. So here, if I execute this, we'll see again that it's going to run all of those in blocks of 2. If we change that value to 4, we'll see that when I press execute, it's going to try and run all of them at the same time. And we can see the Gantt chart really helps us to visualize that. Again, we can see another example. Here we have 10 different values. So we're going to see this loop 10 times, but the concurrency limit is set to 2. So we're going to see this again only run things in blocks of 2. So when I execute this, we'll see it quite clearly in action with the Gantt chart. So as you can see, it's running everything in blocks of 2. Obviously, there are a bunch of tasks together. It's got 2 sets of task runs per loop. And as you can see, it's working its way down the full list of 10. And we can easily see the number here to figure out how far through we are. And just like that, we can see it ran everything in blocks of 2. But if I was to change this concurrency limit to 0, what we're going to see is it's going to try and run everything now at the same time. And so it's going to get very, very long and very complex. But this is where we might see a performance hit because now we have so many task runs happening at the same time. And as you can see, it's slowly working its way through. But this is maybe something that if it got a little bit more complex, we want to move it over to ForEachItem. We're going to revisit ForEachItem again. So here I've got a simple subflow here. It's going to take a JSON input and then simply log it to our logs. Now let's create our ForEachItem that will pass the data to this subflow and then repeat many times. Now here is our parent flow. We're going to download an object from a HTTP request. We're going to convert that from a JSON to an ION format. We're going to then take that ION format, take it back to a JSON. Then we're going to pass it to the ForEachItem. Now here, what we're going to be able to see is it's going to process each of the rows in that file one at a time, but there's going to be a lot of data here. So let's have a little look at what this might look like. And as we can see here, it's processed the data and then it's created 13 executions for that. And if we go to outputs, we can actually see that there is obviously quite a bit of data here. This is much better suited for ForEachItem, especially where you want to pass in a URI or a file rather than maybe a preset array of values. And as you can see here, it was able to create a bunch of different executions, as we can see here. So to summarize, ForEach is fantastic if you've got a small amount of data that you want to simply loop over that's quite simple and it's not necessarily in a separate file or downloaded with a URI. Whereas ForEachItem is much better suited where you're going to have many task runs because whereas ForEachItem is much better suited if you've got a much larger data set that you want to loop through, because instead of creating many task runs, it will break this into a separate execution to help prevent performance issues. If you have any questions about that, let us know in the comments below or join our Slack community where you can discuss with us there. And remember to give us a star on GitHub.